Now we need to talk about the pink elephant in that room, or the pink elephant on the stage, or should I say the snake? Mark, what is it about?
We need to talk about Python, so rock Python. And we already heard it in Lucas's keynote. You can run Python, right? So I brought a screenshot. It's perhaps hard to read, but with version 15, you can go ahead and in the Zenon Logic Studio create Python scripts. And you can either edit these Python scripts within the Logic Studio itself, or you can configure Logic Studio to open Visual Studio Code and do your development of your Python scripts there. And of course, this is not the best of it, right? You have a function block that can actually execute the Python scripts from your Logic Service Engine. So you have your Python scripts running whenever the Logic Service application has a demand for it. But in the end, this is still not the best part of it, because there's an interaction possibility between the logic service, the variables, the values in the logic service, and the Python script. So you can exchange data, you can exchange information between the Python script and the variables running in your logic application. So you take the logic service integration field bus driver, which you can see here in the screenshot. You configure the variables that should be accessible in your Python script, and you can basically import the Python data server wrapper in your Python script, and by simple method call and passing string variables, you can exchange value information with the running logic service. And of course, this is not limited to just the variables and logic service. As you know, we have the integrated solution with the logic service. So we have the logic service to service engine field bus driver, and any variable that you have in the service engine with a simple setting a checkbox is then also available in your logic project. So your variables from your 6150 ID clients, you have them in your logic project, and then you can access them in your Python script. So this offers numerous possibilities. People that graduate from universities, right? They have learned Python, and they may not know about POCs or ladder logic, structured text, or function block diagrams. So this provides them an easy introduction into the world of control and automation. But also for data scientists, of course. I mean, Python is their go-to language. All of the major libraries, all of the interactions for machine learning, AI, deep learning, supervised learning, reinforcement learning, they are done in Python. So, really.
A great opportunity, you can say. Thank you, Mark. So this is kind of future ready, I would say. So Python has, we have an interface now where you can directly integrate Python code into Zenon or Zenon logic applications. Great. One thing we haven't touched here today yet is IEC 61850. And Klemens, what have you got with 61850?
Well, first of all, a question that basically every engineer has nowadays. How do I get to my IEC 61850 devices faster? Because we already heard this today, the more time you spend setting these things up, the more money it costs you. And to be able to solve this transversion in here, so from a configuration file to project content, we right now in version 15 have the IEC 61850 configurator available for you, which is basically speaking an add-in that you can execute within the engineering studio, and it takes over one of the supported configuration files like an SCD file, basically printing out the content that it has, so the logical nodes, the servers within. You can just select the things you want to import and you want to have and configure optional fields. And when you're really done with this, everything else is automatically created with this IEC 61850 configurator. So all the variables that you have inside, all the status variables are created if you want to have them. All the reaction matrices that you need are going to be created. Everything basically that you want to have right now, as you can see, a lot of things within. So in case you find a faster way to achieving this, please let me know, because then we have to integrate this.
Thank you, Klemens. Let's go further. So, yeah, you have a good feeling for the applause, because now we are done with the Zenon 15 things, features and functionalities we wanted to present to you, which are relevant for the energy automation industry. The next things that we are presenting is future, near future. That means things that are already in development. What we want to do with that is to give you a good feeling that COPA-DATA with Zenon is going in the right direction, that you see, okay, these things are coming in the future, I am future safe with that product. So, where do we continue? I think, Mark, it was your turn now. Is that right? No? Yes. Here we go.
So definitely, yeah, we need to talk about future topics, and of course 6150 we just saw, 6150 Configurator in the engineering studio, allowing to easily configure your substation network, all of your IEDs, your servers. But Zenon is not the only thing that's evolving, right? We bring out Zenon 15, Zenon 16, with something that we're working on right now, and also standards evolve. So we heard from Fred yesterday, IEC 6150 was celebrating a birthday, large one, yes. And of course 61850 keeps evolving. So we are at edition 2.1, and some parts of the standard are already at edition 2.2. So what does it mean for us as a component provider, as a developer of a 6150 client and 6150 server, including the stacks? Well, we need to, of course, also adapt our solutions to those standards. And of course, we could do that if there's a demand from the market. But there's actually a thing that's happening, and I think it's a very good thing. The UCA, the International User Organization, has basically decided that after a new standard of IEC 61850 has been released, the test procedures are adapted, and you can only test according to the previous edition for a select number of years. So they're basically enforcing progress, and by bringing out new versions of the 650 specification, enabling new use cases, and basically bringing all vendors on board to also develop the products that implement these standards. So we've been working on edition 2.1 compliance with the goal to certify our client implementations and our 61850 server. And yeah, currently you can see it's pending for the 61850 client in Zenon Logic. Well, the changes for 61850 edition 2.1, they basically happen mainly under the hood. So you don't see that very much. But you do have benefits from new things that are defined in edition 2.1. For example, functional naming, but also enhancements in the logic service 61850 client with greater ease of engineering from SCL files. And while we're talking about the future, I mean, if version 16 is my today, is your tomorrow, I also brought a topic that's maybe the day after. So I wanted to talk with you about PQC and why it is relevant. So today we rely on secure communications, right? Not just within the Zenon software platform, with the Zenon network, with the communication between the process gateway and the control center, securing 104 or DMP3 or 650 MMS. Of course, the communication to the IoT services. We also have other secure communications in and around our substations. We have remote access. Well, can you imagine what would happen if remote access gets hacked? Maybe you have a service provider who is doing remote access for you? Well, there's a thing, it's called Q-Day, or Y2Q. Some of you remember Y2K, that was a thing. And this is basically the moment where they say, yes, there are quantum computers available that can basically decrypt or calculate very quickly the asymmetric cryptographic algorithms that we use today. So RSA-based encryption or elliptic curve-based encryption. Today it's safe, right? Today if you use TLS 1.2, 1.3, you're still secure. But there are predictions, and Fred mentioned predictions yesterday and quoted Niels Bohr, that predictions are difficult, especially if they're about the future. But someone needs to do, let's say, some predictions. And Gartner predicts that basically by the end of this decade, our current cryptographic algorithms that we use, RSA for key exchange or elliptic cryptography, they're going to be broken, and by the mid of the next decade they're completely hackable. Why? Because progress in quantum computing is taking a flight. Commercial companies are onboarding, companies like Google, IBM, they're developing different kinds of quantum computers with the goal to, let's say, solve complex problems. While a computer today may take a few million, trillion years to break RSA cryptography, a quantum computer could potentially do it in the next decade in mere seconds. So why do we speak about it today? There's a thing that is called harvest now, decrypt later. So what we have to assume, and we have to assume that today there's no quantum computer that can actually break this communication, but what we have to assume is that there are entities, nation-state entities, that will harvest data, that will harvest secure communications. And today, they will collect the data of secure communications. They cannot break it today, but as soon as there's sufficient resources, highly stable quantum computers with sufficient qubits, then they will use those quantum computers to go back in time, break the communication, and see any secrets that are inside. So companies already today, they are acting. And I think it's also time, at least for us, to think about this problem that will hit us at some point in the future. I mean, predictions, there are predictions. So what we've been doing for version 16, at least already, is basically we updated our implementation for the secure communications that we use within the software platform. So there's a thing that's called hybrid key exchange, and it uses modular lattice-based key encryption method. There's lots of words. In a sense, it's basically providing a backward compatibility method to use cryptographic algorithms that are considered safe, post-quantum safe today, in a way that a new system supporting this post-quantum cryptographic algorithm can still communicate with an older system. And if both systems support this hybrid key exchange and support version TLS 1.3, then they would use this new algorithm and your communication would be secure even if it is captured now and a quantum computer would be available tomorrow. So this will be available to you with version 16, and yeah, basically the first step for us to get ready towards quantum computing.
Great, thank you, Mark. I like that. I wouldn't think about that. So I'm so happy that we have people like you in the company thinking so far ahead into the future. But Dominic, what will be new regarding Zenon and Linux in version 16?
Yeah, so I already talked today about the Zenon network under Linux. So we have the option, as you have seen, to use the Linux service engine as a server connected with different Linux clients and Windows clients. And with version, we are now very soon bringing also the fail-safe network to Linux. So that means we will also then support the Linux network redundancy. So you will have the option to set up a primary server under Linux as well as a standby server under Linux that takes over all the operations if the primary server connection would fail or if it breaks down because of any reasons. And so you basically are then also secure and have an plan B. And here with this primary and standby server under Linux, you can then of course again connect it with multiple headless Linux clients and also Windows clients, as we have seen already before. And just to mention it, this is of course not the only option where you can use the Linux clients. In this configuration, you would also of course have the option available with the, as you have already used to know, the primary server and standby under Windows, also of course connectable with a headless Linux client or multiple headless Linux clients and other Windows clients. So coming soon also the option to run both primary server and standby under Linux.
Thank you very much, Dominic. And we switch again back to Klemens about what topic?
Well, we talked about security so far, so the whole quantum computer stuff, but there's one thing we haven't touched yet, and it's the integrity of Zenon itself as a system. And before that, I will take the opportunity right now for you to be able to understand the underlying problem, because every new and really grand feature starts with a grand problem. You all have these, if you were down at the wardrobe. So a piece of paper written, in my case, 126 on it, where my stuff should be. But is it really there? Yeah. The fact is, we don't know. And even yesterday it proved out to not be like that. So we have, in fact, no guarantee that our system files for Zenon are the files that are unmodified and really there. So we have right now a feature in progress that is called integrity control, which will also for you guys from the energy business has an impact because it is requested also by the BDEW white paper in two sections. The section 1 is 4.1.9, where it states it must be possible to check system files, applications, etc., through cryptographic checksums. And in there are two important parts, system files and application parameters. So if you consider Zenon as the system itself, it means Zenon files have to be checked and all its content as well. And the second section is section 4.5.5, where it states the integrity of data processed as part of security-related activities shall be verified prior to processing. This means that when you are an operator, the system has to ensure before you use your data actually that this data is not modified. And kind of a neat thing because Klemens Neureiter kicked off within his keynote with a few heroes of his time when he was a kid. So I thought of, when I did this presentation, actually I did not know, heroes back at my time when I was a kid. And I'm pretty sure all of you know this guy. Dagobert Duck sitting on all his values with a gun in his head and trying to maximize his values and protecting them. And in this case, his treasure vault is Zenon. So every data within represents value. And I am allowed to cite Fred again in this presentation in here, because he said yesterday, there is evil energy out there and bad guys trying to do bad stuff. You also have the Beagle Boys, which are on the one hand side trying to break into Zenon's treasure vault, getting things out, but also maybe covering things that they are doing and basically eradicate every evidence that they were in there. So what we want to do is bring in the zenonizer, or our integrity control, which highlights to the operator, please be careful because your data has been corrupted. So what we are planning to do is integrating checksums into Xenon's binary files. So all the recorded archives, events, alarms, basically your whole production things, recipes, recipe group manager, etc. Checking whether these things are consistent when they are used. And in case there is an inconsistency, highlight which files are affected. This is the key message for this whole integrity control.
Thank you, Klemens. We are short in time right now. But anyway, thank you to everybody of you. And as we have touched a few points for the near future, the release of 2026, I want to give you an even further outlook into the future. We heard a lot of challenges already. So there is this challenge of making engineering faster, reduce costs, and so on and so forth. And therefore, we have gathered roughly a few points that we are investing in the future. So these numbers here are not year numbers; these are version numbers, and this is not a roadmap. This is just the plan of the industry management, with a few discussions with Lukas Bunzenberger, who is actually the one that decides then if we do it or not. But I thought in the energy automation family, we can share thoughts about where we are going to invest. One thing you see up there is IEC 62150, and this is, as we heard today, an ongoing journey. There will be new additions, not only 2.1, there is 2.2 for part 6. There is edition 3 in the planning, so over the next versions, and I'm sure this is an everlasting project. Then web visualization and platform independence. We talked about this, and I also disclaimed it already. There are not all features there yet, and of course, also this is an ongoing thing, and this means also we already started it. So that's the reason why they start on the very left. Other things like role-based access control and certificate management, which is necessary to fulfill some special cybersecurity requirements, they will maybe start in one of the next years. So we have a kind of a prioritization, which you can see here. Also, the renewables needs special support, not only from the core product, but also from our possible extension of the power plant controller, which is developed independently from the core product. And then, our strategy is that we want to grow out of the substation with adding new features and functionalities. We should we will invest into the extension of these algorithms. And engineering, as I said, is this smart object. So SO stands for smart object, where we want to enhance the concepts for energy. Now, coming back to my story in the beginning, you remember that the event that changed my life completely was this training in Vienna in 1995. But what did I learn there? I learned that it is possible to create an HMI while avoiding or saving a lot of money for these fixed panels, so the key and lamp panels. Although we did not avoid them totally, we did not trust computers at this time to run 24/7, 365 days a year. And at this time, xenon redundancy was not yet invented. So, but we could build them much smaller, as you see here. Just for these emergency cases, the PC was down. But the general operation was always through the computer screen. The gentleman that you see here is a person few of you might know. His name is Andrei Medved, and he's now working for Sprecher Automation. He should be here, unfortunately. He needed to go undergo a surgery. All the best from here to him. And yeah, I thought it might be cool to have somebody on a photo that is perhaps here in the room. These are the screens, how it looked like. I was so fascinated about these screens. You know, in this room, particular room, you click on a button and then you turn around, you look out of the window, you see the switch yard, the 110 kV switch yard, and you see the disconnector moving. This was so cool. And another thing what was cool was that we could avoid paper writers. Because paper writers had the problem, they ran out of ink, they ran out of paper, and nobody knew. And so we used just the extended trend. And yeah, a trend so you can only run out of hard disk drive at this time. And the second thing is alarming. You know, alarm lists, the alarm status line. You knew in clear text what it is and when it came up and when it was cleared and maybe when somebody has acknowledged it. Whereas with this key and alarm panel, you just knew what. Okay, with that, you are here and you have gained some insights about things that we couldn't even imagine 30 years ago. And you're utilizing an ever-developing software that helps you to tackle the today's and the future challenges of energy automation. Thank you.